In this tutorial, you're going to learn 4 things. First, I'm going to show you step by step how to install Scilab from scratch. Second, I'm going to give an overview of the layout and main toolbar functions of Scilab. Third, we are going to have a look into the preferences menu and adjust Scilab to our needs. And last but not least, we are going to have a quick intro into defining variables, creating plots, writing scripts, and defining functions. In order to install Scilab, open your web browser and type in the address bar scilab.org. Hit enter. With the scilab.org webpage open, you have two options. You can go on the download link, or you can choose one of the Scilab versions in the lower part of the page. The last version in my case is Scilab 2024, so I'm going to go and click on that. I would advise to go for the last version because it has all the function updates and all the bug fixes. So click on this. Now you have to make a choice function of your operating system. Since I'm using Windows, I'm going to download the Windows installer. So click on this link. Choose your destination folder where your installer file is going to be saved, and then click Save. Once the installation is complete, open the folder. What you have to do now is double click on the executable file and the installation will start. Bear in mind that on Windows you have to have administrator rights to be able to install the file. So double click on it. After you agree for the installation file to be run, you have to select your setup language. Since I'm going to use English, I'll let the default settings, but you can click on language settings and can decide to choose another language. So click OK. The Welcome to Scilab Setup Wizard window is opened. You have to click Next. On the license agreement window, you can either read the license agreement by scrolling to the bottom, or you can just click on Accept the agreement and then click Next. You may choose to change your installation folder, or you can leave it by default as it is. If you want to choose it, click on the Browse button and choose a different location. If not, leave it as it is and then click Next. You have several options for installation. You can do a full installation, which I advise to do if you're a beginner, because it will install all the modules coming with Scilab. If you want to remove some of the modules, you can choose to have a custom installation and then uncheck one of the modules. In my case, I'm going to do a full installation, so I'll leave the full installation setting and then I'm going to click Next. Before you click Next, just make sure you have enough space on your hard disk drive. So the current selection requires at least 631 megabytes of disk space. I've just clicked Next. Now you're being asked if you want to associate the file extension with Scilab. I would advise to leave them as they are, and also create a desktop icon setting checked, and you'll have a desktop icon for Scilab. Click Next. Before the installation process starts, you'll have a summary of your settings. Have a look, and if you want to change something, click on the back button. If you don't want to change, click Install. The installation process has started, and depending on your machine, it's going to take a few minutes. So sit and wait until it finishes. After the installation is done, you will see the completing Setup Wizard window with the option of launching Scilab after you click Finish. So we'll just leave that checked and I'm going to click Finish. Scilab opened, so you can see it's installed. Now we can type a command in it. So in the Scilab console, just type VER and hit enter. VER is an instruction it's short from version, and it will give you the Scilab version installed. It will tell you the operating system and some information about a Java plugin. That's it. You have installed Scilab. Thank you for watching. On a Windows operating system, in order to launch Scilab, click on the search icon in the taskbar and type Scilab. If you have several versions installed, you'll see all of them. The one we are going to use for today's tutorial is going to be the 2024 version. So click on the icon. Once launched, this is the default display of Scilab. As you can see, you have 5 windows. On the left hand side, you have the file browser. This is your working folder, and in this folder you're going to save your data and also you're going to save your script files. You can leave the default folder as it is, or you can change it to according to your preference. To change the working folder, click on the browse button and choose the folder you want. Otherwise, if you're happy with the settings, just cancel and leave it as it is. In the middle, you have the Scilab console window, and here is where you enter all your Scilab instructions. Let's give a couple of examples to see how it works. Let's define a few variables. Let's say variable A equals 1, and then variable B equals 2. You see, every time I assign a value to a variable, I have to hit enter, and then it's going to be stored in the variable space. Now, if I want to add those two variables, I will just define a variable C equals A plus B. And we have variable C equals 3. Now, if you want to clear what has been written in the console, you have two options. You can either write CLC and then hit enter, or you can choose the clear icon in the toolbar, this one. On the right hand side, you have 3 windows. One of them is the variable browser. As you can see, it stores the variables which we defined previously, so we have A, B, and C. In the middle, you have the command window. This window stores all the instructions you entered in the console. The utility of this is that if you want to reuse an instruction, instead of writing it again, you can click on it, select it, then right click, and then say evaluate selection, and it's going to be evaluated again in the console. And the last window on the bottom right corner is your news feed. In this one, you just get the latest news from the Scilab website. You can use the left and right arrows to navigate through the news. You can set up the layout function of your needs. For example, if you don't need the newsfeed, just close it and then adjust the size for the remaining windows. You can also move the windows around by clicking on the window name bar, which becomes blue, and then click, hold, and drag. So now I can move my command history in a different place. If you want to move it back, again, click on the name bar, hold, and then drag it across. Usually you will use the file browser window, the console, and the variable browser. You can also use the command history, but in my case I'm not using it that much. If you close a window, let's say we close the command history window, if you want to put it back, you can go in the applications menu and then click on command history. The window will pop back, and then you have to just click on the name bar, hold, and then drag it in place where you want it to be. If you have done a lot of changes to the layout and you're not happy with them, you can go and put the default layout back. To do that, you have to open the preferences by clicking this icon. And then in the general menu under this layout, you can click on the reset layout button. You'll get a message saying that in order to restore your default layout, you need to restart Scilab. Click yes, and then click apply, and then OK. We can exit Scilab by typing exit, for example, and then hit enter. And now if we open it again, we will see that the initial layout has been restored. That's it for the Scilab layout. Thank you for watching. If you want to clear the command history, you can right click on one of the instructions and then say clear history. One important mention is that every time you select a different window, for example, file browser or console or variable browser, you can see that the menu in the toolbar changes because you have different options for different windows. Let's explore the menu for the file browser. You can use the green arrow to navigate through the previous directory. The home icon, if clicked, is going to send you to the default home folder, and the Scilab icon will send you where the Scilab is being installed. For example, in my case, Scilab is installed in D program files. So by clicking on the Scilab folder, your default directory becomes the installation directory. To go back to the previous folder, I just have to click on the left arrow. You also have a Scilab help icon. If you click on it, the help browser will open. You can navigate through the menu and understand how each functions work depending on your needs. If you want to get rid of the help browser, just click on the close icon. If you click on the Scilab console window, you'll see that a different set of toolbar icons will appear. We'll go one by one and explore each of these icons. The first one is used to launch SciNotes. Click on it. You'll notice that a new window appears with an untitled file. The SciNote is a place where you edit your Scilab scripts. A script is basically a collection of Scilab instructions which you can save as a text file, and then you can use later to edit, and you can also execute. So let's give it an example. Let's define two variables, a and b. A equals 1, b equals 2, and then the third variable, c equals a plus b. If I want to save this script for later edit, I can just click on File, Save As, and I will give it a name. The extension for Scilab scripts by default is .sce, so I will add the extension to the file name. Click Save. After saving, your script file is going to appear in your working folder. If you close SciNotes, you can open it back by double-clicking on your SC file. To run your script, you can click on the execute button, which is this icon here. So click on it. You will see a message in the Scilab console saying that your file has been executed. And then you will see also all your variables in the variable browser window. The next icon is for opening a file. You can click on it. You can choose the file to open. For example, I can open my script. Click on it and then say open. You're being asked if you want to restore the last session of your SciNotes. You can say yes, okay. And then you have your script file back. You have a module manager Atoms icon. If you click on it, you will see that Atoms library opens. So Atoms is basically a collection of different functions built by users in the Scilab community. So Scilab comes with some built-in functions which are going to be accessible if you install Scilab. But if you want specialized libraries for different domains like signal processing, linear algebra, instrument control, and so on, you can install a Atoms library. Let's take an example and go to the number theory folder, click on it once, and then click on the number toolbar. You will see that this toolbar, this library, comes with a series of functions which are not built in within Scilab. So if we want to use these functions, we have to install the library. The way to do it is by clicking the install button. After the installation is complete, you will see that the icon of the library becomes green, and then you get a message saying installation done. For the library to become active, you have to restart Scilab. Before we restart Scilab, we'll choose a function which we want to use. Let's go for the numbers prime function and see how it works. So close the atoms library, exit Scilab by typing exit in the console and then hit enter. Now open Scilab again. Now that Scilab is open, we are going to use a function in the numbers library, and that function is called number primes. So let's type it in the console. And give it an argument of 37. This function is going to display all the prime numbers from 0 to 37. Hit enter, and you see it works. Now if you want to remove an atoms library, go back in the atoms menu by clicking this icon. Navigate to your library, which was in number theory folder, and then click on the number library. To remove the library, you have to click on the remove button. Now the library is removed. For the changes to take effect, you have to restart Scilab. So click on the close button for the atoms library, and then close Scilab by typing exit in the console. Now you can restart Scilab. And we are back to the previous setting. The next icon to look into is the Xcos one. So in the toolbar menu, click on the Xcos icon. Two new windows are going to be open. One called Palette Browser Xcos, and another one, it's a block diagram called Untitled. For this video, we're not going to dive into Xcos, but in short, as Xcos is equivalent to Simulink from MATLAB, and it's a block diagram editor in which you can define your function in a visual way using blocks, but then you can run your functions and simulate them, seeing the outputs. So for now, we'll just close the palette browser and the untitled diagram. The next button is preferences, so we are going to click on it. So in this menu, you can set up your Scilab in terms of display, layouts, and default folders. So we'll go one by one. If you highlight the general menu by clicking on it, you can see that you have a bunch of options for the environment, language, Java, and startup. The one which you might use is the startup directory, where you can have a default directory when your Scilab starts, or you can use the one set by default when you install Scilab. If you click on confirmation dialogs, you'll see you have three settings. You can choose whether you want warnings before you exit Scilab, warning before you delete command history items, or a warning before you clear the console. I would suggest to uncheck all of the options, because when you do one of these instructions, you're sure you want to do it, so there is no point of being asked again. So uncheck them and then click on apply. Next setting looks after desktop layouts. This one is useful if you want to restore the layout to the initial setup. Some preferences you might be interested in are the colors. In this one, you can decide how to color the syntax for Scilab instructions. For example, you have here different instructions like comments, mail links, or hyperlinks. You can also customize your latex code and also the syntax for a function. I usually leave these as they are, but you can, if you want different colors, you can use these settings. On the console menu, you can choose how many lines of instruction you buffer in the console. Usually I leave these settings to the default value. In the Xcos menu, you can decide how many files are going to be open when you launch Xcos. If, for example, if you in your previous sessions you had 5 files opened, when you relaunch Xcos, you'll have the same number of files opened. On the edit menu, you can decide how your lines are going to be drawn. So I will leave them on straight, and then you can also decide whether you want to grid on your block diagram file. Also, in the simulation menu, you can decide your integration time, final integration time, and also some settings about your integration parameters like absolute tolerance, relative tolerance, and also integration methods or solver. I will leave all these settings as they are by default. So after you have set up your preferences, if you've done any changes, you can click on apply and then OK. Otherwise, you just click on the cancel button. Next icon to look into is the Scilab demonstrations. So if you can hover your mouse above this icon and then click on it, you will see a list of demonstrations. These ones are basically step-by-step tutorials which you can use to learn Scilab. For example, let's click on the introduction one, and then you have 7 tutorials. You can call on, let's say, the first one, Scilab objects. And then you'll get a message saying that you need to press enter in the console to proceed step by step. So click OK, minimize this window, and then in the console just start hitting enter. So you see, you can go through the tutorial by hitting enter every time you want to see new instructions. If you want to finish the tutorial, you have to click on Ctrl and X, and then the tutorial is finished. Next icon in the toolbar is the help button. So if you click on the help browser, you will open the help menu for Scilab. The help menu is organized function of libraries and function of different categories. If you want to learn, for example, which are all the functions used for graphics, you have to go down, expand the graphics menu, and then look for the function you want. One easier way to navigate is by clicking on the search icon and then type the name of the function you want to learn about. Let's take, for example, the plot function. We'll just write plot here and then hit enter. You will get a series of results, but the most relevant one is the first one. So if you click on it, you'll see that you get the help file for the plot function. If you're done with the help browser, you can click the window by hitting the X icon. Now you have a good understanding on how to set up your Scilab layout and also what are the icons for every window. Let's start with the definition of scalars by taking a practical example. Let's assume you want to calculate the force by multiplying a mass with an acceleration. So in order to write the equation of the force, we can use comments. In Scilab, to write comments, you can use the slash key. So if you type // and then any characters you type is not going to be interpreted as a numerical input, is going to be interpreted as a comment. So for example, let's say F equals m times A, and that force is going to give us the result in newtons. So this is a comment. If I hit enter, nothing is going to happen. You can see there is no variable defined. So you can use comment either in your Scilab console to explain what you're going to do, but the best place for the comment is when you are defining a Scilab script. I'll give some examples later. Right. Now let's define one variable m, which is our mass. Let's say m equals 50, which is kilograms. If I want to put the unit, I can put a comment and I will put / and then say kilograms and then hit enter. As you can see, I define my mass as a variable m and has the value of 50. Now I will define another variable called a, which is acceleration, and this will be, let's say, 6 meters per square second. So I'll just say 6 and then / for a comment. You don't have to type the comment, but it's useful if you want to make sure you take the units into account. So I'll just say meters per square second and then hit enter. Now I want to calculate the force, so what I'm going to do, I'm going to say F equals m times a and then hit enter. And I have a force of 300 newtons. Okay. Another thing to take into account is when you type spaces in your Scilab instruction, that space is not interpreted, so you can type, you can have as many spaces as you want. For example, if I define another variable c, I can just have no space and say c equals 14 and then hit enter. Or I can say variable d and I'll have 3 spaces equal another 3 spaces 56 and another enter. So the same result. So spaces, you should use spaces only when you want to make your code prettier and easier to read, but it does not have an impact on how the instruction is being interpreted. So this was an example on using scalars. As you can see from the example, scalars are variables which just contain one numerical value. Arrays are variables which contain a series of numerical values. Let's start by defining a simple array called x. So to define an array, you have to type the name of the array. So say x, and then equals, and you have to have brackets, left bracket, and then right bracket. Inside the brackets, you are going to type the content of your array. So I want an array which holds the value 1, 2, 3, 4, and 5. So what I'll do, I'll type 1 and then space 2, space 3, space 4, and space 5, and then hit enter. So as you can see, I define my variable, my array x, with the values 1, 2, 3, 4, and 5, which I can also see it in the variable browser. The value of the array is not specified because you have multiple values, but you have the size. So if you want to see the values, you can double click on the x and then the variable browser is going to open, so you can see the values of your array 1, 2, 3, 4, and 5. Now let's create another array called y, but now I want to use a function, a Scilab built-in function, instead of typing the values myself. So I'll use the function once, which is generating a matrix of value 1 for each element. What I need to specify for this function is just the size of it. So if I want to have an array, basically it means I have just one row, so I'll type 1 for the rows, and I want 5 columns, so I'll just type 5, close brackets, and then hit enter. I generated my array y with 5 values of 1. Now if I want to add x and y, I will create a third array called z, and I'll say z equals x plus y, then hit enter. When you're adding arrays, what's going to happen, you're going to add every element with every element. So you're going to add 1 plus 1, 1 plus 2, 1 plus 3, 1 plus 4, and 1 plus 5. You can also perform array operations without assigning the result to a certain variables. Let's, for example, assume you want to do x minus y. So you just type x minus y and then hit enter. So you'll get the result. If you're not assigning that result to any variable, by default Scilab will create a variable called ans, which comes from answer, and this variable you're going to see it also stored in the variable browser. Now let's start defining some matrices. For example, I want to define matrix A, which has 3 rows and 3 columns. So to define matrix A, I will type A equals, and I will open right bracket open, and I will type my first line, we'll say 1 space 2 space 3. Now to define your second line, you have to type semicolon and then type the values for your second line, and I want to have 4, 5, 6. Again, semicolon, and now you have to type the values of your third line, which will be 7, 8, 9, and close right bracket, and then hit enter. Right, now I want to define another matrix B, but this time I'm going to use another built-in function, which is called rand, which comes from random. So this function rand generates a random matrix with the values between 0 and 1, and those values are randomly generated. So to generate that matrix, I'll have to use the function rand, and I have to specify the size, which is 3 lines and 3 columns. So I'll type 3, 3, close the bracket, and then hit enter. I generated my matrix B. One thing to take into account is when I use functions, I have to use the round brackets. Yeah, you see, this is round, this is round. When I want to generate matrices by typing the values, I have to use right brackets. Yeah, open right bracket and then close right bracket. So try to make this distinction, and don't switch them off, because you're going to get an error. Now that I have my two matrices defined, I want to perform some operations. So what I can do, I can create a matrix called C, which I want to be equal with the product between A and B. So I'll type A times B and then hit enter. You can also perform built-in functions for matrices. One of the functions, I think, is to calculate the determinant. To calculate the determinant, you have to use the function det. So I'll just take det of C and then hit enter. So the determinant is given down below. This was the example for matrices. Now you can play a bit with it. So define your own matrices and perform some operations. Let's define a couple of strings and perform some operations with them. So we'll start with, let's say, string x equal to the string, say, Joe. In order to define strings, you can either use double quotes, as in my example, so Joe, hit enter, and we'll define another string called y, and then we'll give the surname black. Now, instead of using double quotes, you can also use single quotes. Let's say black, and then hit enter. The result is the same. We defined two strings, one x, another one y. You can see them in the variable browser. Now you can't see the value of the strings, but you can see the type as being the string. Now if you want to put those two strings together, you can just add them. So you can say string z equals x plus y. Hit enter. Now you got string z Joe Black. If we want to have a space between Joe and Black, we can do repeat operations. So now, instead of me writing again z equals x plus y, I can just press on the keyboard the up arrow, and it is going to populate the last instruction that I've done. So now that I have this already in the Scilab console, I can just go and between x and y, I'll put another plus, and then I'll put a space between two double quotes, which means basically now that I'm adding three strings. So I'll add string x plus string in the middle, which is a space, and then plus y. So if I hit enter, now you can see that string z is the complete name Joe Black. Scilab has a lot of built-in functions which you can use to manipulate strings. One function that we are going to use now is called length. This function can be used with strings or with arrays. So what it does is going to return a number, which is the length of your string. So if I type length of z, then hit enter, I'll get the value 9, which means my variable z is a string which contains 9 characters. In Scilab, a variable of type structure groups together several other variables named members. The separation between structure variable and members is done using the dot character. For example, I have a structure called x, and for this structure I want to assign a member called name. So what I'll do, I'll type x.name, and then for the name I'm going to assign a string, which is Joe Black. For the same structure x, now I want to assign a age, so I'll say x.age equals 34, and then hit enter. As you can see, the structure x has two members, name Joe Black and age 34. The advantage of a structure is that you can group different types of variables like scalars, like strings, or also matrices in the same structure. So if I want to assign also a matrix to x, I'll say x dot, say my matrix, and I will give a random matrix of 3 lines and 3 columns, 3, 3, and then enter. The variable x, being a structure, is displayed in the variable browser with a particular icon, the name, and then the type structure. If you want to see the values of it, you have to double click on the name, and the tree overview is going to be open. And in the tree you'll see the members of the structure, name, age, and my matrix, and then the values for these members. In order to create a Scilab script, you have to open SciNodes by typing SciNodes in the Scilab console and then hit enter. Let's start by defining a variable called theta, which I wanted to have it as an array between the value minus pi and 5 pi. So I will type minus, and then pi is a Scilab special variable, and special variables, they start with the percentage symbol and then a name, so I'll have pi. You can see that it turned out in a pinkish color, which means it's a predefined Scilab variable. So this is my start value of my array. Now I put double dot, which means that now I'm defining the step in my array, and I want the step to be pi divided by 100. So I'll write pi divided by 100, and then double dot again, and and now I have to enter the last value of my array, which I said is going to be 5 times pi. So what is this instruction going to generate? It's going to generate an array between minus pi up to 5 pi, and the steps in which it increases is going to be pi divided by 100. Right, now I want to calculate a new variable called y, and I want y to be sinus of theta. So I'll say sin as a function, and then as argument I will write theta. So these are my new two of my arrays. Now I want to create a function, and this function I want to look at every value of y, and then when y is bigger than 0, I want to take that value and multiply by 2, and then when the value is less than 0, take the value divided by 2. To be more specific, I'm going to use comments, and I'm going to explain what the function should do. So I will say / I say my function z, which is function of y. So I'm just using the comments to explain what I'm going to do next. These comments are not going to be interpreted by Scilab when I run the script. So I say my function z, and the function should do if y is bigger than 0, then z is going to be equal to y times 2. Otherwise, so else, I want z to be y divided by 2. Yeah. So just 3 lines of comment to explain what the purpose of the function is. Now I'm going to use the loop for to go through each value of y, and then I will use conditional statements if to check every value of y. So I will just write for. Now I have to enter a index variable, which is going to call it k, and k is going to run from 1 up to the length of y. So I'm going to go with a for loop through each value of y, and I'm going to check if that value of y is bigger than 0. To do the check, I'm going to use a conditional statement if, and I'll say if y of k is bigger than 0, enter, I want that the function z of k, will be y of k times 2. Else, I want z of k to be y of k divided by 2. And then I have to finish my conditional statement with the keyword and. Right, so I'm going to explain again what this function does. So the for loop goes through all the values of y, and then the conditional statement checks every value. So if that value of y is bigger than 0, then z of k is going to be the value of y times 2. Otherwise, so if y of k will be either 0 or negative, z of k will be y of k divided by 2. So this is my for loop with my conditional statement. Now I want to plot the results. So I'm going to use the built-in function plot. And how plot works, you have to assign the x value and the y value. So my x value is theta, and my y value is actually y. Now you have several let's say customization options for plot. You can specify the width of the line which is going to be plotted. So I'll use the property called line width, and I'm going to assign the value 2. So what this will do is going to make the line of the plot a bit thicker, so it's more visible. Now I have the initial y plotted, but on top of it I want to plot also z. So I'll write again plot theta as the x variable, and now I want to have z. Again, I want to have a thicker plot so the line will be visible. So I'll say line width equals 2. Right, if I can save the script as it is. Save as. And I'm going to assign and I say my script .sce and then hit save. You can see now the script appeared in my file browser window. To run it, I have to click this button, which is called execute. So click it and I get an error. So it says undefined variable length, which is wrongly spelled. So it's it is length EH. Yeah. So yes, and then you see if you get a predefined function, the color changes into light blue. Before was black, which meant I made a mistake. So now I have the right one. What you can do now is click this button which says save and execute. So you'll save the file and then we'll execute. So click. After running the script, you get this plot in which you see you have two lines, and the problem is you can't tell which one is which. So in order to correct this, what I'm going to do, I'm going to assign different colors for those for Y and Z, and for that I'm going to after Y in the first plot command, I'm going to say double quotes, and I'm going to put an R, which is a keyword for red. And for the second one, I'm going to put double quotes and K, which is shortcut from black, right? Now I'm going to save and execute again. So as you can see, now I have the right colors. So Y is red, so it's this one, and Y is black, so it's this one. Now, other customizations which I want to do is add the grid to my plot. So I will just write this built-in function X grid with no arguments. If I save and execute again, I'll have a grid added to my plot. Next, I want to add a label for my X and Y axis. So I will say X label, and then brackets. In the brackets, I want to add a latex code in my X label. So I will just use double quotes, and then inside double quotes, I'll put dollar signs at the beginning and the end. And if you want to write any latex code, you have to start with a dollar sign and then end with a dollar sign. And this is going to be interpreted by Scilab as latex code. So I want to put my variable theta, and then I'm going to put the unit as radians. So I'm going to write text of space bracket rad. So all this is a between dollar sign at the end and dollar sign so dollar sign in the beginning and dollar sign at the end. This is latex code. So you can see how it's going to look like on the x-axis is like this icon here. So it's theta, like Greek letter, and then space, and then radians. Now I'm going to use another keyword called font size, because I want to increase the font size of my X label to be more visible. So I'll say double quotes, font size, and then I'll give the value of 4. Okay, so this is the X label. I want also to put the Y label. So I say Y label, brackets, and then I'm going to just type Y and Z in quotes. So Y, comma Z. And I want to increase the font as well. So I'll say font size equals 3. So run again, let's see what we get. As expected, I have the X label is theta in radians. So this is a latex notation because I use latex code. And then I have Y and Z on the Y axis. But I would like also to add a title of my plot. So I will say title. And again, I need to use double quotes because it's a string, and I'm going to write my function Z equals Z of Y. Right, and then save and run again. You see, I get my title up there. And the last thing I want to do, I want to add a legend, because I have in the same plot, I have two curves, one Y, one Z, but I don't know which one is which. So I'm going to say legend. And how legend works, you have to assign the first string is for the first line. So I plotted Y first. I'm going to say Y, then comma, the second line, which is Z, I'm going to type Z as a string. And then you can assign the position of the legend. So if I say 1, the legend is going to be placed in this corner. If I say 2, it's going to be this corner, 3 here, and 4 there. So I want to have it here because I have more space. So I'll type 2. Okay. Save and run, execute and run. So unfortunately, I have the same colors, blue, blue. Why is that? Y and Z. I closed the previous figure window, and then I'm going to run the script again. So you can see now I have the Y plot and the Z plot with different colors, and I have the legend in the right place. That's it for this lesson. I hope you enjoyed it, and I hope this example is going to open more opportunities for you. So start using Scilab, start writing some code, and let me know in the comments below if you have any issues or if you need help. Thanks for watching.